Hello and welcome to the next session of our webinar series. My name is Johannes Braun and I've been working for Track Machines Connected as a sales manager since last year, summer 2024. Today I have the pleasure to give you an overview of our offerings concerning the high precision point cloud, the digital twin and our digitized inventory service. There are further sessions and I would like to make you aware as well on these upcoming webinars. On the 29th of October, there will be the next webinar and another one on the 26th of November. And you are welcome to participate in these sessions as well. Before we start with our webinar today, let me introduce TMC, who we are. We, TMC, are focused on railways, or to be more precise, we are the railway dedicated IT and software expert. TMC was founded in 2019. Today we have more than 100 employees. Our headquarters is in Austria at Linz. There are further sites in Austria, in India, and the United States. TMC is cyber security ISO 27001 certified, and our products and services, they are tested, they are real, and they are in use on real machines and in the track. We are proud to be a member of the Digital Railway Solution Alliance and the Allianz Pro Schiene. Meanwhile, we have more than 150 customers in more than 100 countries. After this introduction, let me continue with a question and answers. Who is this webinar for? To which person, companies, or entities we can support, we can provide benefits and added value with our offerings of the point cloud and the digitized inventory service. First of all, there are the infrastructure managers and the infrastructure maintenance companies. This is due to the higher demands for digital documentation for safe and cost-efficient operation and maintenance. There are the infrastructure planners and surveyors. We can provide an important part for the building information modeling. And there are the signaling planners. We, with our point cloud and the digitized inventory, we can provide an important part for their signaling planning for the track, the PT1 planning. And finally, it is for the project managers or site managers of turnkey systems. With our input, we provide an important part for the time scheduling or time change diagrams, the planning, and as well the control of the work process of sites. I will continue with the results we provide. Here you see a colorized high precision point cloud. As you can see, there is no need to go outside anymore into the field, into the track to see in person objects along the track, or to do measurements. This is not needed anymore. You can do all this virtually. You can do measurements in the office using this point cloud to measure distance from the rail, for example, as you see it here, to the bridge, or you can measure the coach, a lot of other things that you can virtually observe. Look to the objects which along and in the track. I will continue with further results or images from our point cloud. Here you see some images of a point cloud from the project at Offenburger railway line. This is a project we have done jointly with our partner Obermayr Infrastructure in Germany, or this another project. This is a Riedbahn railway line in Germany. This project we have implemented in the second half of 2024 together with our partner Obermayr. So let's have a look to this, how we produce or we generate these results. First of all, let's have a look to the principle, and this is as follows. First of all, there is the automated track surveying with the digital systems, which provides a high accurate absolute track access. And with our mobile mapping system, we merge the captured LiDAR and RGB data with the digitalized surveying data. So the result is the point cloud, which we merge with the absolute track axis. The result is a colorized high precision point cloud. All this we do with our application, the Digital Environment Twin Service, so-called tmDETS. Let's have a closer look in this system to the components and the process. The track geometry system, the POS-TG, is an inertial navigation system which allows for the measurement of the relative position of the track. And there is the tmRTG. TMC's reference track geometry system allows for the measurement of the reference points alongside the track. This is a system combining a stereo camera, which you see here in the upper picture, integrated in the measuring vehicle, and the track side reference point. The reference points must be equipped with special designed markers, as you see it here in the lower picture, which allow for reliable detection. This system provides the offset between the reference points and the rail and the track axis for the horizontal and the vertical component. Here you see a small image film where you see the vehicle with the stereo camera system and then the recognition of the markers or the reference points. Finally, there is the tmATG. The determination of the absolute position of the track axis is realized by combination of these two systems, reference point system and the track geometry system, the tmRTG and the POS-TG. This will be done in a multiple step process. The coordinates of the reference points are used for the correction and localization of the track axis. Let's move on with TMC's mobile mapping system, or with the components of our mobile mapping system. There are two measuring vehicles available. These vehicles are fully equipped with the calibration measurement systems and with the mobile mapping system, the Regal VMX system, which consists of an IMU, an inertial measurement unit, a global navigation satellite system, 3 LiDAR systems, and a color or 2 color camera systems. So with all this resulting in a digital full service process, starting with a track survey, with a measurement car, with its measuring equipment. In the back office, there will be the generation of the high precision point cloud and the AI-based data analytics. And finally, this all results in a categorized high precision point cloud, an inventory, which we provide as a service in a geodata package. Furthermore, there can be done an update of drawings and log reports, which shows the differences from old drawings to the updated ones. Let's move on with the accuracy and the productivity. The accuracy requirements was for the homogenized point cloud, a relative accuracy of 1 centimeter and 5 centimeter. Our systems tested and accepted with the accuracy what we achieved for the relative accuracy of 1 centimeter and the absolute accuracy of 2 centimeter. This is how accurate we provide our point cloud. Now let's move on with how effective and how efficient our systems are. So it's about the productivity and cost optimization. Already the initial measurement is more cost efficient than conventional manual methodologies. For the initial measurement, if you compare it with our digitized or automated measurement, you have already a cost advantage. Then there is no need anymore for track closure. There is no costs related to this because there are no track closures. Our measuring rights, our measuring on our surveys with a measuring vehicle, we will do always without any interference of the conventional traffic operation. And because of this, there are no people in the track. There are no related track safety costs for safety guards and safety people to protect the workers or to guide the workers. And in case there are remeasurements to be needed or there are anything like this, you have the data available in the point cloud in the office, so you can redo it 24 hours, 7 days in the office. There is no need to do any manual remeasurements. These are the advantage, the effort advantages and cost advantages of our system in comparison to the conventional way. Let's move on to the second topic of our webinar. It's our digitized inventory as a service, what we offer here. On the upper, here you see an overview of the process. On the upper left corner, this is what I explained already now before. This is our the data recording and the data preparation to provide a point cloud. With our inventory as a service, we do an automated object classification with AI-based and software, and also with conventional algorithms. There are additional assignments of attributes for each object can be done also afterwards or in this process included. These data can be then transferred to a designated system of the customer. So in the end, there is an inventory database, a digital database, a geo package, what we provide here. This is one thing. On top of this, what very often you get as from the infrastructure manager drawings, CAD drawings from an old status. This, what we do here, we process these data, we compare these data, these drawings with the actual inventory list, which has been digitized, which has been updated. And out of this comparison, we update the drawings, and also what we provide is a deviation log. So these are the results out of this inventory service. The applied methods are the following. First of all, there is a video-based track capture by the RGB cameras, and we have a YOLO, so-called YOLO model based, which recognize, based on the AI, these several objects. For example, in this picture shown, there are signals. It's far away, but the system recognized already here. It's yellow marked with a yellow square. There on top, or in parallel, there is a laser-based track capture model. In this model, in the 3D point cloud, there are objects already categorized through the process and classified. All this together, in the end, using our AI, we recognize meanwhile more than 35 object classes. These objects are, I call it small dimensions, or must signals, something like this. What is in progress now to recognize as well with our AI linear objects, for example, noise protections, cable trays, and something like that. Here you see a combined view as it is in the AI algorithm. So there you see here the object classes in this case are the overhead catenary musts, and here you have the combination of the RGB image and as well of the point cloud. You see this overlapping the points in green on these musts. What you can do also after this process, you can do a manual post-processing to give more attributes to the recognized objects. Here you see, for example, a lamp mast. Your interest might be the top of the lamp itself of the mast, that you set a point and that will be georeferenced, or in this next picture on the right side, you are interested on the area of the surface of the foundation. So you set the points, you can measure this, and this can be added to the attributes of this object. So you get more and more a full picture. It depends on what you are interested in these objects. Finally, I will give you the overview of the whole process, how it works. First, on the left corner, you see already far away these signals, the signals must, and the AI recognized already in this with this RGB image the signal must. As a blue square, you come closer and it's confirmed. Then out of this, there is an automatic extraction of the individual object as a point cloud, and this results in the end in a list, in a geo package with certain attributes. So let me summarize what are the benefits of our digital twin service and the inventory as a service. This is time and cost efficient in comparison to conventional methods. There is a high-speed measurement with the vehicle and without any track closures. The digitized process with the AI-based asset recognition saves also costs and effort. Overall, there is an improved safety for the track workers, so safer track work through automated surveying and digitized data evaluation. There is no stuff anymore in the track. The results are accurate and precise and updated. You have 24/7 access to the track actually because of the point cloud, what is in your system. There's an unlimited availability of information to any point en route to take measurements. And you have an up-to-date digital inventory. This is provided by a digital asset database. And finally, what we provide are revised site plans and design documents, detailed change logs, and deviation reports. That's it from my side, first of all. Here you see my contact. If you are interested, please contact us. We are always ready to evaluate projects, and very often we do a first step with a proof of concept. So there is not too much effort for all parties to show you what are the added value of our system. If you have questions now, please put it in the chat. And afterwards, of course, I'm always as well available. Okay, I got a first question in the chat. It's who owns the data which we collect in the field? The owner of the data is always the infrastructure manager. Are there further questions? If not, there are some further. Do you offer? Yeah, I guess here's the question. Do you offer post-processing of railway data captured by other systems? Yes, this we do. It needs not to be the point cloud what we deliver. It can be also from another system. And what is else? What's the first step? What's the first step to initiate a project? Please contact us. Then we will evaluate with you together what your needs, what your demands, and so we can proceed. Looking to the screen if I got another question. So how long does it take to collect the data of assets on average? It depends, of course, of the complexity of a track, but usually you can say that we can do in one shift, depends on the traffic and so, but in one shift we can do more than 50-kilometer double track to measure with the car in the field and to collect the data. And now what is, who coordinates the measurement of the trackside control and how we control absolute accuracy in areas with no line side markers? Okay, first with no side markers, and we have now these reference points or markers, we can do still point cloud with GNSS precision. But of course, then you will not have this accuracy, but depends on the requirement or the request or the project needs, this will be sufficient. Was there a further question? Is a 5 centimeter enough to control the dimension of an, you mean that we recognize an object which has a dimension of 5 centimeter? This should be possible, yes, because we have this combination of the RGB camera and the point cloud. This will be sufficient. Is there anything else? I don't see it. So then, thanks a lot, and I'm always available. Please contact me also after the webinar. I'm ready to go the next step with you in a new project. Thanks a lot.